Okay, this video is a key to page 1 of your review worksheet for Chapter 7A, and I've got all the problems completely spread out on this sheet that are not spread out on your sheet, but so I can show all my work. So in this one I'm just adding these three numbers, so it's really just one long addition problem, except I'm subtracting the 2 plus 7i, so subtracting 2, subtracting 7i, adding 7i. So the 7i's cancel each other out, and I have a 6i, and then I combine the negative 8 and the negative 2, so I've got negative 10 plus 6i is my answer on that one. Number 2, I'm just going to, this means literally multiplying negative 5 minus I by negative 5 minus I, and the pattern is I'm going to get the negative 5 squared, which is 25, and then, plus 5i plus 5i, so plus 10i, and then plus I squared. So I squared is negative 1, so this is really 25 plus 10i minus 1. So the real part is a 24, and the imaginary part of this complex term is 10i. So in number 3, I'm just multiplying three terms, negative 4, 4i, and negative 4 plus 2i. It doesn't matter what order I do these in, what I multiply together first, so I'll just multiply these two together first to get a negative 16i, and then multiply that by negative 4 plus 2i. So my first term, I'm going to get a 64i, and then a minus 16 times 2 is 32i squared. So I squared is negative 1, right? So this becomes a positive 32. So it really is 64i plus 32, because it's minus 32 times negative 1. So I'm going to rewrite this as 32 plus 64i. Okay, and then in number 4, again, I'm just going to multiply these using distributive property. So I get 15 plus 5i plus 9i, so plus 14i, and then plus 3i squared. So there's a negative 1. So it really becomes a minus 3. So it really is 15 plus 14i minus 3. So 12 plus 14i. Okay, on to number 5. Number 5's got three complex numbers that I'm adding. So it's really like I could just take away all the parentheses. So I have 4 plus 3i plus negative 3 is minus 3 plus 5i plus 1 plus 6i. So on the real parts I have a 4 minus a 3 is 1 plus 1 is 2. And on the complex parts I have a 3i plus a 5i is 8i plus 6i is a positive 14i. So it's pretty simple, just combining like terms. Number 6 has a little more going on because I have this product. These two complex numbers are being multiplied and then added with these two. So once I add with these two, I'm going to be adding a minus 8 here, and a plus 7i, and a minus 3, and a minus I. So when I multiply these two together, I'm going to have 40 for the first terms, minus 56i, and on the middle terms plus 25i, and then plus 35i squared. So the negative 56i and the positive 25i is a negative 31i, and the 40 and the 35i squared, it's like I'm combining a 40 and a negative 35, so that would be a positive 5. So it's really one long expression here, 5 minus 31i minus 8 plus 7i minus 3 plus I. So real parts, I have a 5, a negative 8, that gets me to negative 3, minus 3 is a negative 6. What did I miss? I'm supposed to have a negative 86. Oh, this was a negative 40. Sorry, the 8 times negative 5, that should be a negative 40. So negative 40 minus 35. So this should be a negative 75. Okay, so negative 75 minus 8 is negative 83. Minus 3 is negative 86. And then negative 31i plus 7i would get me to a negative 24 minus 1, so negative 25i. And that's the answer on that one. Okay, so I missed negative 40 right there. Okay, so moving on to number 7. I've got to simplify this rational expression here, and I see that I have an I in the denominator, which is like having a radical in the denominator, so I'm going to get that out, multiplying this whole thing by 1 in the form of I over I. So I get a negative 10I in the numerator, because I have to distribute that, at minus 6I squared. And I get a 3I squared in the denominator. So when I multiply this by the negative 6 by negative 1, it becomes a positive 6. So in the numerator, I'll have my negative 10I plus 6. And then this is a negative 1, so I'm going to move a negative 1 out to the front of the whole thing. And that's a 3. So when that negative in the front, if I want to distribute that over both of those terms, I'll get a positive 10I minus 6 over 3. That's the way your answer key shows it. However, if we want to put this in a plus bi form, I would put the negative 6 first over 3 plus the 10 over 3 times I, and this would simplify to a negative 2. So negative 2 plus 10/3 I would be in a plus bi form for that one. So when possible, we're going to try and write them like that. Okay, number 8, I just have a single I again, so I'm going to multiply by 1 in the form of I over I. So I get in the numerator a negative 5I, and in the denominator 2I squared, which is a negative 1, which will change this. I have a negative, and then over a negative 5I just becomes a positive 5I over 2 as my answer on that one. Okay, so then down to number 9. And number 9 kind of squished up a little, but the only way to get this binomial with the I in it out of the denominator is to multiply it by its conjugate. So the conjugate to negative 5 minus 5I is negative 5 plus 5I. So this is being multiplied by 1 in the form of negative 5 plus 5I over negative 5 plus 5I. Okay, so I'm going to do that problem down here. So then in the denominator, I'm going to have negative 5 squared minus the second term, which is 5I squared. So I'm going to have, let's see, 25 minus 25I squared, which is 25 minus a negative 25, or 25 plus 25, which is a 50. So my denominator is going to be 50. And my numerator, I'm just going to multiply these out. 1 times negative 5, 1 times 5I in the numerator. Let's see, that would be a positive 10I. And then negative 2I times positive 5I would be a negative 10I squared. So let's see here. This becomes a negative 1, so that's going to change this to be a positive 10. And my 5I and my 10I combine. So I have a positive 10 minus a 5 is a 5, plus 15I all over 50. And that will simplify more. So if I factor out the common 5 that's in all three of those rational parts there, then I would have a 1 plus 3I all over 10. So if we want to put this in a plus bi form, then we've got 1/10 plus 3/10 times I. Okay, and number 10, oh boy, we got the same thing to do. At least we have more room. 8 plus 4i. So I'm multiplying by 1 in the form of conjugate over conjugate. Again, in the denominator, I'm going to get the first term squared minus the second term squared. Should be 64 plus 16, but let's just work it out. So 64 minus 16i squared, which is going to be 64 minus negative 16, or 64 plus 16, which is 80. So denominator is 80. The numerator, we get a negative 48 minus 24i plus 24i plus 12i squared. Okay, so the i's go away, and then negative 48, and this becomes a negative 12, the 12i squared. So negative 48 minus 12 would be negative 60 over 80. So canceling out the 10 over 10 right there, I get negative 6/8, which is simply negative 3/4. Okay, so that's kind of all the manipulation that you have to do with the those terms that involving complex numbers. And so that was kind of from lesson 6.8 in your book. So now we're going into what you should have in your notes about graphing the numbers in the complex plane. So 4 is the real part, and the 2 is what we call the imaginary part of the complex term 4 plus 2i. So to graph that, I go over 1, 2, 3, positive 4 on the real axis, and then up to 2 on the I-axis. Okay, so right there, that is the point 4 plus 2i. Okay, so then in number 12, I have a point, and I have to tell what it is. So this is 1, 2, 3 at negative 3 on the x-axis and on the real axis, and on the imaginary axis, I'm down at negative 2. So that point is negative 3 minus 2i. Okay? So, number 13, we're supposed to find the discriminant and state the number of solutions and the type of solutions. So with this first one, I want to get everything on one side. So I think I'll subtract x squared, let's leave a 0 on the left, minus x squared gives me a 4x squared on the right. And then I'm going to subtract 13x, so minus 13x minus 13x is a negative 8x. And then plus 4 plus 4. Okay, so the discriminant is b squared minus 4ac. So the b is negative 8. And the a is 4, and the c is 4. So I get here 64 minus 4 times 4 is 16 times 4 is 64. And that means that the discriminant is 0, which tells me when it's 0 that I have 2 imaginary roots. I'm sorry, not 2 imaginary. I have one double root, one rational double root. When it's negative, it's 2 rational. Sorry. Okay, so I have one rational number that's a double root, right? Sorry about that. Okay, and then in number 14, we'll go through the same process. We're supposed to do the same thing. So I have a negative 5n squared here. I'm going to add 5n squared to both sides. So I'll have a 9n squared plus n plus 3 is 0. So the value of b squared minus 4ac. The b is 1. So it's the coefficient to this n, which is just a 1. So 1 squared minus 4 times a is 9 times c is 3. So this is 1 minus 36 times 3. So 3 30s is 93. sixes is 18, so negative 108. So I get 1 minus 108, or negative 107. Now because the discriminant's negative, that tells me that there's two imaginary conjugates as roots. Two imaginary solutions, they're conjugates, right? In A plus BI and A minus BI. Okay, so we were not asked to solve those, just tell the nature of the roots. So then in number 15 and 16, which are the last two for this page, we're going to solve by taking square roots. Okay, basically using the square root method. So notice I just have the squared term and then I have constants, numbers. So I'm going to add the 8 to both sides here. So 7x squared equals 378. And so I'm going to divide out the 7 on both sides. So 378 divided by 7 is 54. So x is positive and negative square root of 54. So let's see, so we have, this is a, let's see, 54 is 9 times 6, 9 being a perfect square, so 6 will stay in. So this x then is equal to positive and negative 3 root 6. So that's two solutions as promised by the fundamental theorem of algebra, 3 root 6 and negative 3 root 6. Oops. All right, and then the last problem on page 1, same kind of thing. I have 3x squared, and I want to get numbers on the other side, so I'm going to subtract 4. So I get negative 25. Oops, 3x squared is negative 25. So I'm going to divide both sides by 3. And so x squared is negative 25 thirds, and now I'm going to take the positive and negative square root of both sides. So x is positive or negative square root of negative 25 over 3. So I know an I has to come out, and a 5 is going to come out in the numerator. So let's go one step at a time here. Positive and negative I. So I'll have a 5 in the numerator over the square root of 3. So I can't leave the square root of 3 down there, so I want to rationalize that denominator. So I think my final answer is x is positive or negative. Let's go with the 5 root 3 all over 3 times I. So on your answer key, they're showing this as 5i root 3 over 3 and negative 5i root 3 over 3. So they moved the I to in front of the radical, which is fine. So that's it for page 1 of your review worksheet.